Everyone loves Wordle, but have you ever thought that AI could play a fairly good Wordle game? Stay tuned for this episode of the Cozy AI Kitchen. Delighted to have here, live from Michigan, Chef Jennifer Marsman, one of the most influential people in tech and AI and ML, making top 100 lists, stuff like that. Chef Marsman, welcome to the Cozy AI Kitchen.
Thank you for having me. Excited to be here.
I'm so glad you're here. I heard it's cold in Michigan. Is it cold in the fridge today?
It is very cold here in this fridge, yes.
How about that? It works that way.
And in Michigan as well.
So you work in the office of CTO as a principal engineer. You're like, you're like the dream of engineers who sort of hit this level. Can you say a little bit about what you do there?
Yes, so I do three things. I write our CTO's demos, and I work with customers to help them meet their technical challenges, and I do analysis on new models. And what I'd love to share with you today is like a combination of those. So I was exploring the capabilities of the first GPT model to have visual capabilities, which was GPT-V at the time. And all of this you can do with GPT 4.0 right now as well. But I wanted to see if I could get it to play Wordle for me. I actually thought this was a really fun challenge for a number of different reasons. It involves so many hard problems. Like when you think about visually, the amount of different things you have to do when you play Wordle, you need to know the position of where the various character is within the word. You have to know the actual character, the OCR part of it, and you have to know the color that is behind the character to be able to use the logic to know where to put it in the final word. So that was a lot of information.
That's a lot to work with. And can you back up a second? You said 4.0. What does the O stand for?
It stands for Omni. So Omni just means that it has multiple modalities. It has capabilities of visual as well as audio and other things besides text.
Oh, so it can do all this color stuff we're talking about. Really cool. Oh, can't wait to see it.
Yeah.
Yeah.
Yeah. So I was thinking about the image understanding, and that should work. Do you think your readers would need to be refreshed on how Wordle works?
I think everyone can. Thank you.
Okay. So the way you play a game of Wordle. So Wordle, first of all, was this just spot of joy during COVID. I think that was what you kind of got me through the day. I'd have my coffee, I'd do the Wordle, and for 5 minutes pretend that everything was all right. So in Wordle, you guess a 5-letter word. And when you guess, you have to provide a real word. So it does have to be you can't, if you wanted to guess a K, L, and an M or whatever, you can't just put a string of characters. You have to put an actual word in for every single guess. There's a new Wordle every single day, and you have 6 tries to guess the right word. And so when you put in a word, what will happen is that the color behind each letter will change. So it will turn green if that character is in the word and in the right position. It will turn yellow if that character belongs in the word but is not in the right position. And it will turn dark gray if that character is not in the word. So that color information is going to be really important to help us solve the puzzle.
So wait a second, Jennifer. This is something I have a few friends do that. One does it with their daughter, and it's a daily activity. This is hard for humans to do too, right?
It is. It's a challenging problem, but it's a lot of fun. But I thought it would be so fun to see how a machine could do it. I wasn't sure if it would be possible at all. But just the fact that you needed these 3 distinct visual capabilities made this seem like a really good test for the vision understanding capabilities of the model. So I thought it would be fun to try it out. Because you need that position, that OCR, as well as the colors. So that's 3 things that I knew those were all hard for image understanding models, especially positioning has been super hard for a long time with these models.
So that
plus it was fun. I got to play Wordle every day to solve this. So that was great.
So you're harnessing all this omni energy in AI.
That's right.
Cool.
That's absolutely right. Yeah. So I started with Hello World. So the way I just wanted to see was there any information about Wordle in the training data, for example? So the hello world of an image understanding model is just to send it an image and say, describe this image. And so I put in something like that, and I used the Wordle board that it shows here. And this was the reply that the model gave me. So this actually tells me a lot of information. It tells me that the model does know what the Wordle game is, that it has an understanding of the Wordle's words kind of baked into the training data. And it did a fairly good job of getting some of the data right. It was able to identify the words that were guessed, but it didn't get all of the details correct. So everything I have highlighted in yellow here is things that are wrong about this puzzle, about the model's output. So we have our work cut out for us, John. We need to figure this out.
And that was the first generation model, correct?
That's right. So this was the very earliest version. This was actually a pre-release version of GPT-V. So now you'll see this work a lot better. And at the end, I can even show a demo of the O series model, and it can get this pretty easily at this point. But I learned so much going through this process, and the prompt engineering for image understanding models that I learned is really what's interesting to me about this. So the first thing I learned.
As a master engineer, how do you connect prompt engineering to your regular engineering practices?
Yeah, so I find that just some of these little tidbits that I learned from work trying to coax it to do something fun, like play Wordle, you can apply in other scenarios as well where you may need image understanding. So think about things like being able to check on inventory, or other things about, like, if I'm a retail shop, being able to write an accurate description of, I'm going to sell this dress, for example, write up a good description for the listing for that dress. So there's so many other like commercial use cases as well for image understanding. And so the things I learned there are also applicable in other scenarios as well.
You can reproduce your results.
That's right. That's right. Yeah. So one of the first things I did, when you don't get a prompt right out of the box, one of the first things to do is to try few shot reasoning. So all that means is I want to try a couple of simple examples. So instead of just writing, describe this image, what's a good, what's happening in this image, what are the various letters and such, I can give a couple of examples of the kind of output I want, and then that will guide the model to produce similar output in the ways that will help me.
This is the so-called few-shot approach.
Exactly, exactly. And so what this actually looks like, if we want to jump into some code for a second, is I used an example here where here in this method, what I'm doing is I have an image path that I wanted to pass in, and I have just a simple prompt to focus on the letters and colored boxes in the center of the image, list all the ones in green boxes and what column they're in, list the yellow ones and their position. Noticed I was using different words, position versus column, just to add some diversity. And then list which letters are in dark gray boxes, because we don't actually care about the position for those. So that was my prompt that I passed in. And then I had a couple of examples here. And these were examples of screenshots I had taken when I was collecting training data and trying it every day. So that gave me not training to train the model, but for me to help guide with my few shot examples. So I took a couple of examples, passed those in here, and then told the system prompt that you're just a Wordle AI assistant. You identify letters guessed in a Wordle puzzle, what color and what position they are. All right, so really simple prompt. And then instead of just asking the question, what I did was included a little back and forth with it set up the way I wanted it to. So I have the user, I'm passing in example 1 here with that same prompt, and then I'm giving a good output here of the kind of thing that I want. Here's the yellow letters, here's the gray letters, here's the green letters, and I'm including position for those two. So I gave 2 examples of that, and then passed in a second one with similar output. And now I'm passing in with the prompt, here's the actual image that is the input. And then I wanted to see if that would give me better results.
Wow.
Yeah, a lot of times that kind of thing helps, but in this case, it did not. So we still got some colors wrong and some positions wrong. Originally, the character extraction was correct the very first time, but as you know with generative AI, you never run it just once. You have to run it lots and lots of times to see if you got it right. And then on subsequent calls, it was getting the character extraction wrong too. So we're 0 for 3, John. So far, nothing is working right.
You can
So
do it.
what I did, so yeah, so I was like, oh, we need to work here. So I started thinking about how the model was actually representing language under the covers. And so, as you might know, the models aren't using characters or words, which is what we understand as humans. It's using something called tokens.
Yep.
And tokens are actually a little pieces of words. Sometimes it's a full word, and sometimes it's like a subset of a word. So as a fun example here, there's a word standoffish, which means a little bit snooty or aloof. And if you break that down into characters, pretty obviously you can just take each individual letter. But when you tokenize it, that becomes stand off ish as those 3 separate concepts. So ish is, a common suffix in the English language that means, having the characteristics of. And you can actually go to OpenAI's website and see the tokenizer in action.
It's pretty amazing, Jennifer, how, the famous strawberry conundrum with models, you were able to tackle this Wordle universe. Wow.
So this will actually show tokenization right here. So I can put in something like John's king-like behavior, like that. And you can see how it actually tokenizes it. So you can actually show the tokens and how it's breaking it down. So again, apostrophe X, it's a common suffix. King-like, again, it's kind of like that ish, where it's having characteristics of. And then behavior tokenizes all by itself. So each color represents a unique token. So this phrase would break into 5 tokens. So given this, and that's how the model is seeing it, John, that makes you think about, okay, when it's reading each of those individual things in the Wordle puzzle, it may not be able to accurately tell, tokenize those right. Maybe it's not grabbing the characters individually, maybe it's munging them together. So I started thinking about that. And I actually, with some guidance from a blog post that I found online, I saw a really good trick, which was in Wordle, if you put brackets around the characters, that will make just in the text, right? In the text here, that will help cue the model to tokenize it by itself. All right. So I did that next, and I changed it. So my system prompt still looks very similar. I did add some stuff about colors along the way and other things. And then in my user prompt, I did add one other thing. Because we had that few shot, I was worried that it might grab information from some of the previous examples. So I did say at the beginning of my user prompt, here is a new image, just so it would recognize that, oh, I want you to kind of clear the buffer and start thinking about this problem from scratch. All right. And so I added brackets around the characters. So in the code I just showed, those few shot where the assistants replied, I put those characters in brackets, showing that the Y should be by itself, the L and the B. And when you think about the kind of data that it's trained on, those kind of cues, like brackets and such, show that something should be like broken out by itself. And so that actually did the trick. Consistently, I ran this many, many times, again, because it's generative AI, and I found that it's extracting the letters right. Yeah. So we're now one is done. We got one of the things. We have characters coming out correctly consistently. But we still need to solve positions and colors. All right. So I started thinking about some different things. The first thing is chaining, right? So if we could consistently get the letters extracted correctly, then maybe I should just break it into multiple model calls. Like I could make another call that says, what is the color behind the L? What is the color behind the J? And that could help. The other, middle of the night revelation I had was that In machine learning, so long before the days of generative AI, in traditional machine learning, it's well known that open-ended questions are actually harder for the model to solve than classification questions, which is choosing between a couple of known buckets. And so that was another thing where I was like, oh, silly, what was I thinking? So instead of asking like what color is in the box behind the character, when I know it's only going to be one of three colors, I could ask the question in a different way, which is the color in the box closest to green, yellow, or gray?
Cool.
And that will make it much easier.
Wow.
So now we could have some code that looked a little something like this. We call the model, we get the characters, we parse out that information about each character, and then call for each individual letter within our answer, what is the color behind there, and see how that works. And it was not working. So that did not help either. I was still not getting great results. So I went through a process. I tried lots of times. And I started thinking about something else. There was another section in that paper that I mentioned before from our friends at Microsoft Research that they had published right after the GPT-V model came out. And they had a section on dense captioning. Now, I don't actually care about captioning, right? In the example they were doing, they were highlighting some of the luminaries in the AI industry and having it create a caption around each of them with a prompt. But what caught my eye is that it's doing a similar activity where it has to find distinct things within the image, right? Because I don't care about the image as a whole. It's actually like I need it to localize on a very specific part of the image. And I think that's really the hard part for the model, because we've seen that the model can handle like what color is this pretty well, but really zooming in on that particular part of the puzzle and getting that, I think, was the tricky bit. So look at what they do here. They're actually saying to localize each person in here, recognize each person, and then generate the caption. So I changed my prompt to be similar here, where instead of asking for each of the things, I said focus on the letters in the colored boxes, then localize them, identify each one as the right color, and then identify the character, and then last the position. All right, so I just kind of changed the order around of how I wanted it to do that. So focus on each letter and then work through the letters. And that actually worked. It was getting the positions right. So now we have characters and positions. And that's actually super interesting, right, John? Because what I think was actually happening, like if you look at my original prompt and what that looked like here, note that what I was saying is focus on the letters, find each green box and identify it, find each yellow box. So the model was actually having to jump all over the place to look for greens, look for yellows, look for grays. But what I think what actually happened under the covers is that when I changed it to actually be more focused on, just focus on the letters, and then for each one, tell me this, it allowed it to process the letters in a more sequential order that made sense, and then it could hold on to the position better. So that's my theory of why this language now worked and my previous language didn't. Makes sense, right?
I'm so struck by how like a good mechanical engineer works in reality to understand it, even though the physical laws may be different than reality. So I just saw you progressing through so many things using engineering thinking to take apart a solvable problem. But just like the real world has randomness in it, you're doing the same thing, but in the information science world.
That's absolutely correct. It's absolutely correct.
Yep. So cool.
And then that's it. And that's experimenting is really the key. That's how you learn, right? We learn from failure way more than we do when something works.
Yeah, I kind of felt you wearing your backpack, like going through the mountains trying to figure it out.
Yeah,
you
so
had
fun.
me at the moment of the bracket. I was like, the bracket. It was like a kind of Indiana Jones
That's what's in it, right?
moment.
We saw, it's so great.
Well,
all right, but we still got to
Jennifer,
get colors, John. We have one. We're 2 for 3 right now. We're at 2 out of 3.
Oh my gosh, that was so exciting.
We still have to get the colors right. Yes.
Oh,
so
thank you
the colors
so
were
much.
still wrong.
Wow.
So I tried a lot of different things to
Right.
get it to write. I was thinking about like I kind of went through the same thought process as I did when we were looking at like the tokenization of how when we were extracting the characters. I was thinking, how is the model representing color under the covers? I started thinking about that.
Yeah.
I was like, let me see, could it be RGB? Is it hex values? I
Yeah.
know it does like base 64 encoding. So I started playing with a lot of different things to see what I could do. I knew that the same model was running in GPT at the time, so I actually asked, hey, do you know what this character is, just to see if it could recognize what the colors were. So I knew that the model's training data did include knowledge of that training. I was testing that using, techniques like that. So like I know that it knows that.
Right.
But after a bunch of experimentation, I couldn't get it to consistently give me color with the other two. So I decided to isolate one of my variables. Position, so I knew it could extract position on its own, but my suspicion was maybe it couldn't get all three of those things, color, position, and character, all in a single pass. So to test that theory, I wanted to, get rid of one of those confounding variables. So I said, okay, position we can actually get fairly easily from code, right? Because we know that the Wordle board is always 6 items this way and then 5 characters across. So that's pretty easy. I just wrote a little bit of simple Python to do the chunking for me. So we can then have some code do the chunking, just take each chunk, which would be just a letter and a color, and let me try to pass that in and see if that will work to get the color. And then that would confirm for me that the model does in fact know how to get the color. So I tried that next. I don't know about you, John, but I always use rates. I know some people are boring and have the same starting thing every day. I'm one of those people, but I love rates. So what I'm going to do is I made a guess as my first guess. And then I'm just going to take a little screenshot. And then this is my code right here. So you can download this code from github.com/Jennifer Marsman/WordleGPT if you want to try it out yourself. And then running this, I'm going to do this paste. So that just pasted in here the my actual word. And so it's chugging away right now. So if we take a look right here, you can see the various things coming through. So I actually have my R is marked as dark gray. My A is marked as dark gray. So you can see as it comes through that it's figuring that out. And then now it's using some code to figure out like what could be the next option. So we see all of these options right here as a good next guess. So let's try something like, what should we try? That's kind of a combe. That actually adds a lot of new letters. We could try that. And I feel like E at the end is a good thing, although I have no idea what that means. Comb? Is that like a fancy comb? Oh, cool. So that actually gives us a couple more letters. So if we do that and paste that in, we should be able to see it running again. And you can see all of the options that are left. One thing I can do is it actually does rerun each time, so it's going to rerun the rates. I could add some caching in there to make it a little bit faster. All right, so we see a number of different options here. So let's try one of those. And then the other thing that works really well is that you can actually put this in GPT, a reasoning model, and it can do a good job here. But let's just try one of those. Yeah.
Cool.
Yay! Whoa. And we got it. So,
right.
So we did. We were able to solve our Wordle puzzle. So yay! It did do a great job.
Right.
If we want to update, I could do like the options. Wordle. This was gray. The A was gray. The T was gray. The E was yellow. We could see like what options here. I've just filled in all of the information, the updated information that we have here. And then I'm going to ask, what is an optimal word to guess next that will either solve the puzzle or help me gain the most new information? So I'm actually using the O1 model right now. The O1 model it takes a little bit longer to run, but it usually does a very good job. But the reasoning models, actually O1, some of the O1 and O3 mini models run a little bit faster and can do a decent job with this as well. So you can try those if you would like. All right, so from the feedback, we know that the word looks like this, which is great, with an O somewhere in positions 3 or 4, because we know that it can't be yellow right there. So it does that. And so it suggests a strong next guess is clone. And that, in fact, would have been a very good next guess. And that would have gotten everything except for the N right there. So you can see that if you want it to just uh, provide just one guess, you can do that as well. And the reasoning models do an excellent job with that.
I love how really, you go deterministic, non-deterministic, then you add determinism, you use Python to sort of like slice the real pizza of images. So
Yeah.
Jennifer, I think that the visitors to the kitchen are kind of like me, like, wow, that was like Indiana Jones through Wordle. But interestingly, you were solving another puzzle that was different from Wordle in this LLM world plus images. So for those who are tuned in right now, Jennifer, can you help them understand how you made this complex trek from engineer to prompt engineer to full stack engineer and can do things like this? Because everyone wants to know how to become like you.
I think a lot of it is just experimenting. So if you see what I'm doing here so far, I tried a lot of things and they fail. So at the end, it all seems, very smart. But it like when you're going through the process, it isn't. You just keep trying things. Use your mind, consider what could be happening under the covers. And then that's really the secret. And remember too, we learn so much more from failure than we do from success. So every time you you try something and you fail, you've kind of learned something, which can help you figure out what should the next experiment be. And then hopefully after enough experiments and just, raw, just perseverance, you can do something really amazing.
Well, thank you, Chef Marsman, for coming to Cozy Eye Kitchen, taking us through the magic of Wordle and a very complex Vision Omni scenario with all kinds of ways to cook and get to the answer. Thank you for all joining us. Thank you.